Welcome, guys. Welcome to this lecture. In this lecture, I think in the previous lecture, what we did is we have seen up to the basics of structure. I think we have seen how to define a structure, how to find the size of a structure, how to declare a structure, and finally, how to access the members of the structure. Okay, all these things we have seen so far. And now, followed by this, we will just take three examples and we will convert these three examples into a structure. The very first example is just I'm going to take complex numbers. Complex numbers. What is complex number? A complex number is a number which is in the form of a plus ib. A plus ib, where I means where I is equal to square root of minus 1. I is equal to square root of minus 1. So we can say that A is the real part. A is the real part and B is the imaginary part. So taking a complex number, we have two data. One is A, unknown data A, and this A is called as real part of complex number. In mathematics, we could have already learned this. Okay, B is going to refer to imaginary part, right? So now what I can do is that here the entity is called as complex number and the data member are real part A and real imaginary part B. So these two data are associated with a single entity called complex number. So how can I define it as a structure? Actually, first of all, a keyword called struct followed by the name. Let me take it as complex. Okay, complex number, like this, complex number, then followed by the body part, initialization, declaration part, defining part, and inside this I can take two integer value because real and imaginary. Let me assume that it is real, integer. So integer real, first part, A part, and then one more part is integer imaginary. So hereafter, instead of just declaring int real, int imaginary, or a plus ib format, if you want to represent anything, you should not, you no need of going to the going and just declaring like this. Don't go and declare everything separately like this. Int real, comma imaginary. Declaring like this, you cannot understand this real and imaginary means. Suppose you might have 5 or 6 complex numbers. When 5 or 6 complex number is there, what you will do? You will write real 1, imaginary 1, real 2, imaginary 2, real 3, imaginary 3. So this will become confusing. So it is not an organized way of writing a code. For organizing it, only what I'm telling, when you found some data and if these data are related to a single entity, then don't declare it separately like this. Take this data, cluster it together and write it as a structure. Okay, so suppose if you define a structure like this, what is the size of the structure will be? The size of the structure will be the sum of size of the member. What is the size of the first member? For example, let me assume 2 byte. The second member, again 2 byte. So what will be the total memory? 2 plus 2, 4. 4 will be the total memory of complex number if integer is taking 2 byte and if integer is taking 2 byte. Suppose integer is taking 4 byte, then 4 plus 4 will be equal to 8 byte totally. Will be equal to totally 8 byte if integer is taking 4 bytes. Okay, so similar to we are not going to use this and we are not going to do anything, but I'm just showing you the defining part alone. I'm going to take few scenario and I'll write the corresponding structure defining statement. Okay, so we'll just take it off, and now again I will just tell you next example, and the next example is going to be student. What are all the data that is related to a student? For example, first one you can take a roll number, next his name, next one his department, and next one address. For example, your roll number, let me consider that the roll number is integers. Few people roll numbers are in string format also, character format also. But let me assume that a particular student's roll number is integer. Okay, the name will be definitely a integer, sorry, character. Okay, so it has to be of character array. Because why I'm taking it as character array is, already integer array I have shown you. Why I'm just telling this character array means, we told that a single character will be able to store only one single character, but name is not going to be one character. Name is going to be collection of character. For example, like my name is Sachin, right? So double quotes SACHIN, multiple characters, collection of characters are coming. So character array, when I want to store multiple element, collection of values, then what I need to go for? I need to go for array. When I have 5 integer, go for I have used integer array. Now when I'm having 6 characters, to collectively store 6 characters, then I have to come to character array. So character array we will see in a different part. Okay, just I'm telling you that name is going to be a character array. Character array, we have a different you have a separate section. Okay, fine. So next one, coming to department like information technologies, computer science engineering, electronic and electrical engineering, it is also going to be a character array only. Okay, so this is also going to be a character array. Coming to address is also of course a character array. So now we will just convert this student scenario into a structure, and we will just see. So struct followed by the name of the entity, which is student, and inside the body I'll be taking integer roll number, so integer roll. Next one, it is going to be a character array. And what is the character array? Name. And what I told you, if you want to convert a variable into an array, then it has to be followed by a bracket, and you have to specify. So for example, let me specify 25. Let me assume that the name of the student is not going to exceed 25 characters. Then I will just take character, then it is going to be department. So the department name also, I will just consider that it is going to be there in 10 characters. Within 10 characters I am going to write short forms, maximum 10 characters. I'm just assuming. Next, followed by address. So if I want to store address, let me consider that it requires 50 characters. So when I want to store 50 characters, the size of the character array is going to be 50. Don't think about how we are going to use this character array and all that, we will see later, but I'm just showing you the way to define the structure alone. Okay, so now at last we have to give the semicolon at the end of it. So what we have done, we have taken an entity. All the data related to entity are clusterly stored like this. You need not to declare it separately, like roll number, roll name 1, department 1, address 1, roll 2, department 1, department 2, address 2. No, you have to make it organized way, or that organized way of declaring it was called a structure. So what is going to be the size of this? So what is the size of an integer? For example, it is 2. What is the size of a character? Single character is 1 byte, but here totally 25 character spaces. So 25 character means each character 1 byte, so totally 25 byte. Coming here, one character is 1 byte, so 10 character means it is going to be 10 byte of data. 10 byte of data. Then again 50 characters here, so 50 bytes of data. So totally how much byte of data you wanted? 50 plus 10, 60, 60 plus 25, 85, 85 plus 2, 87. So totally 87 bytes of data will be allocated. 67 bytes of memory will be allocated for this structure, not while defining but while declaring it as a variable. Okay, fine. So next, one more sample we'll see. This one more sample is going to be, the next sample is playing cards. Hope everybody knows playing cards. I think so. Playing cards. Okay, just I'll show you an image of a playing card. So if you see here in this image, if you see this image, just see in the same image itself. Okay, so we'll just see the same image. You will be able to see 5 cards, and I think everybody knows this playing cards, right? So coming to a playing card, if I take a card, What are all the data from a card? What are all the data member will be coming? I think one is the number which is there, number. So I can take it as like symbol. Okay, so this number can be taken as like face. Okay, number, that number part we will take it as face. What is this shape? This is shape. This is heart in, this is spade, this is diamond, and this is club, or called as clover. Number is called as face. The symbol, this shapes are shapes, we are going to say, take it as shape. And color, you have two different color, red color or black color. So these are all data which is related to playing card. Am I right or wrong? What are all the data that is related to playing card? First of all, playing card I'm taking. What are all the data which is related to playing cards? First one is face. Face means either A, it starts from A, right? A, 2, 3, 4, 5, 6, 7, 8, 9. No 10 is there. Okay, sorry, 10 followed by J, no 11, instead of 11 J, Q, K. So totally 13 faces are there. 13 faces like this are there. Then the next data member will be shape. How many shapes are available? 4 shapes are available. What are the shapes? Heart, followed by spade, then diamond, then followed by clover or otherwise club. Okay, clover or club. And then what is the third data? The third data is color. What are the colors available? Either red or black. Either red or black. So I take an entity, and what are all the data members related to it? Face, shape, color. So let me consider that the face, I'm going to take it as not a character. I'll just take it from 1 to 13 as an integer. 1 means it refers to A, 2 means refers to 2, 3, 4, 5, up to 10 it is okay, fine. 11 refers to J, 12 refers to Q, 13 refers to K. So we can have face as an integer value. Similarly, coming to shape also we can take it as a integer value. For example, we will have 0, 1, 2, 3, where 0 points to heart, 1 points to spade, 2 points to diamond, and 3 points to clover. And I think heart is of red color, heart and diamond is red color, spade and clover are black color. Similarly, color also what we will do is we'll take 0 or 1. When 0 it is red, when black it is 1. So red is referred by 0, black is referred by 1. So all these 3 data member we can take it as an integer data member. So how we are going to define it? Let us see here. Struct card. The name that I will be giving is card. What is the member? Face numbers. To take that A1, A2, 3, 4, 5, we have this variable called face. Then it is followed by a variable called shape. Okay, shape can have either spade, heartin, diamond, or clover. So 4 symbols, 0, 1, 2, 3, 4 shape. Then followed by color. Only 2 color, red or black, 0 and 1, 0 or 1. So 3 data member I'm having. What is going to be the size of this entire structure? This face will take 2 byte. This shape will take 2, and color is going to take 2. So together, if you just add all these things, you'll be allocating totally 6 byte of data. You'll be allocating totally 6 bytes of data for this entire structure called as card. Okay, fine. So now what we will do is, first of all, I'll just create one variable of this data type struct card. So struct card is the data type, and I'll be declaring one variable called C, for example, one variable called C. How to define the value for, how to initialize the value? 2 ways of initializing. One in the declaration here itself. How we can do it? We have 3 member, right? For 3 member, we will give the values here. Face is going to be 1. Face is going to be 1. What is the shape? Shape is going to be 0. What is 0 shape? 0 shape is heart. Heart means definitely it will be red only. So red means 0. So 1, 0, 0. So what this is indicating me, this is indicating that we have taken a card, and that card is a red card, and it is having a on it. It is having a on it, and it is of heart in. It is of heart in. So we have taken a heart in a, we have taken a red color heart in a card. Okay, fine. So what if you declare this, what will happen automatically? A block will be created, a memory block will be created with 3 blocks like this. A cluster of block with the 3 independent blocks created like this, for example. Okay, you can see, able to see. So 3 blocks are allocated, where the first block refers to face, and the second block refers to shape, and the third block refers to color. And the name given to this entire memory block is C. You can see here, card C. So the name given to the entire memory block is C, and you have 3 members there, and for the 3 members 3 memory block is created. And what is the value that you have given? 100. So what will happen here? Instead of face it will store 1, instead of shape it will store 0, instead of color it will store 0. Fine. If I need to access anything in this either of this 3 block, what I need to do? Variable name dot member name, variable date name dot member name, variable name dot member name. So you can either give c dot face, or you can either give c dot face, c dot shape, or c dot color in order to access it. Okay, fine. So now what is the next thing that we will do is that I will just introduce you to, or otherwise, see, if you can just declare like this, you can initialize the value here itself, or otherwise what you can do, c dot face is equal to 1, c dot shape is equal to 0, heart in. C dot color, if heart in is a shape, then definitely color has to be red, which is defined by 0. So either you can declare that way, or you can declare this way. Okay, now I'm going to convert this structure into array. Why I need to convert this into an array? Because if you see here, if you take a card, with one card you cannot play. You cannot play a game with one card. You need to have at least a deck of cards. What is a deck of card? A deck of card means it is a cluster of 52 cards. In this 52 cards, what you will be having? 13 cards in heart in, and then in diamond, if you see, in diamond you will be having 13 cards. What is this 13 cards? 13 cards means it is from A to K. A 1 2 3 4 5 6 7 8 9 10 J Q and K. These are the 13 cards from A, not A1. It is A2 3 4 5 6 7 8 9 10 JQK. These are the 13 numbers. So 13 cards from heart in, 13 cards from diamond, 13 cards from spade, and then 13 cards from what is the one more we left? Clover. So together, if you add all this thing, you will have 52 cards. So totally a deck of card is equal to 52. These things you could have seen in mathematics. A deck of cards equal to 52 cards. So if I need to take 52 cards, what I have to do? I need to have 52 such variables. 52 such variables. How to have 52 such variables? Do I want to do like this? C1, C2, C3, like this. If I have to give to up to C52, no, this is not going to be a structure. This is not going to be an organized way of writing a code. Lines of code will be very large if you write like this. So instead of having 52 cards, instead of having 52 variables separately, what you can do, you can take the C1 for 52 times. So the same C, only one variable you have taken, so change it to 52. So now how, see, I told you that similar to integer, struct card is also a data type. So when an integer variable can be converted to an array, then your structure variable also can be converted to an array like this. So when you convert a structure into an array, what will happen? Just show you here. So you are having a block like this, right? So instead of having a block like this, I'll just show you how this block will be created actually. Sorry, 1 minute. Fine. So now if you see, one block means it is okay enough, but if it is 52 means, you see here, the next consecutive blocks, the next consecutive blocks, the next continuous block, the next continuous block, it keeps on going like this. You'll be taking 52, you'll be taking 52 such kind of blocks. But in order to explain you, I'll just take only few of it and I'll show you how this is going to be stored inside. Okay, so I'm not taking 52 such blocks, I'm just taking 1, 2, 3, 4, 5. I'm taking only 5. So what is the how I will be differentiating? This is first block, this is second block, this is third block. It is similar to an array. When you take array, what will happen? First block is given index called 0, second block is given index called 1, third block is given index called 2. Similarly, this first block is given the index called 1, the second block is given the index called 1, third block is 2, next comes 3, next comes 4. So hereafter what you can do is that if it is first card, means first block, which means C of 0. In C of 0, what you have to do? Color C of 0, color C of 0 means it refers to this first block, this 3 together. So this 3 together you have face, shape, color. So C of 0 dot face, C of 0 dot shape, C of 0 dot color. Similarly, C of 1 dot face, C of 1 dot shape, C of 1 dot color. So what you can give? C of 0 dot color is equal to 0. C of 0 dot face is equal to 1. C of 0 dot shape is equal to 0. So before we were using only C, now we have made it as an array and we are using C of 0, C of 1, C of 2, C of 3. So C of 0 is first card, C of 1 is second card, C of 2 is third card. Here it goes on up to 51, index number 51. So C of 51 will be the 52nd card. So you have taken 52 deck of card. You can ask me whether I will be able to initialize in this way. No, one more alternate way I will tell you how to initialize it. Open a curly braces here itself in the declaration line itself, and inside this, how I think totally 52 deck of card, right? For each deck of card you can have a set of curly braces for each and every deck of card, for example. So you can say this curly braces, this inner curly braces is first card, referring to first 0th card. This is 1th card, this is second card, and this is third card. So inside this, what you do is you give 1, 0, 0. Okay, next one is 1, 1. 1 means it refers to spade. Spade means the color is black. Color black is referred by 1. Next, the card 1, but diamond. Diamond is referred by 2. And if it is diamond, the color is red. Red is referred by 0. The next card, I'll take ash. Ash of it is going to be clover. Clover is going to be black. Clover is referred by 3 and black is referred by 1. You can keep on defining like this by giving 52 set of elements like this inside a curly braces. So you can keep on giving. This is in this way also what you can do. You can define the array of structures. So hope you understand this. So now what I will do is I'll just show you few. So I have now only taken 4 cards. I can leave the remaining part also. You know that in array itself I told you need not to allocate all the blocks. You can allocate few blocks also. For example, you can allocate 5 blocks. I have shown you this example. Int a of 5. And there is no necessity that all the 5 blocks has to be assigned now itself. I can give 1, 2, 3 and I can stop. 1 comma 2 comma 3 and I can stop. What will happen? First 3 blocks will be allocated this memory and the last 2 blocks will be automatically changed to 0. Similarly, here we will check what is going to happen. We will also, what we will do is we will just print f percentage d percentage d percentage d in order to print 3 members. C of 2. It is not first card, it is not 0th card, it is not first card, it is second card, this card. In this card, what I will do, I will just print all the 3 one. Face followed by C of 2 dot shape and then followed by C of 2 dot color. So now if you see this, we'll just we will just execute this and we'll just check. You see here C of 0, C of 1, C of 2. The C of 2 data is being printed here. C of 2 data is being printed here. Now what I will do is I'll just show you the line by line traversal from the first line, very first line I will show you. Okay, I'll just show you the line by line process here. Okay, so see here, the straight away your execution came inside your main function. So main function is the starting point, it is the entry point. So automatically activation area is created for your main function, and you can able see here you have created a variable called C, and how many blocks are there? 52 blocks you can see here inside. 52 cards have been taken, playing cards have been taken, up to 51. If you expand one card will be having 3 data like face, shape, color. All these 3 things are filled with some garbage value. You can able to see here. Don't think that this is 0. No, it is also garbage value. So you can see here in everything you have some garbage value inside, because till now you have not declared anything. So now what I will do is we will just execute this 10th line. Just execute this 10th line, and now I will just expand and I'll check the 0th one. Here if you see face 1, shape 0, color 0, the first one. Second card 3 1 1 1 1, it is displayed here. Then coming to 2 1 2 0, then followed by 1 3 1 will be stored in third index. Yes, 1 3 1. Now I will expand 4 and check 0 0 0. I'll expand 5 and check 0. I'll expand 6 and check 0 7. Now if you see, no garbage value is there, no garbage value is there. So once you at least declare only one set of card, all the remaining set of cards will be automatically changed to zeros. All the members of the remaining cards will be changed to 0. This is the same thing that I showed you in the array part. Okay, this is the same thing that I showed you in the array part. Okay, fine. So this is enough for the structure so far. Okay, so what we have learned is how to define a structure, like this. By taking many examples, we have defined the structures like this. Then how to find the size of the structure, then how to declare a structure like this: card C, card A, card C, card C1, card C2, something, some variable. So how to declare, then accessing member using the dot operator, how we have to access it. Then we have also seen character array also, sorry, structure array also, how to convert a structure variable into an array, that also we have seen. Initialization part also I have shown you. And also here visualization part, visualizing the same thing in the compiler also I am showing you. Okay, so this is enough. So for continuing further, this is enough. Okay, so what we will be doing is in the evening session. Okay, in the evening session we will start by clearing. Few people have asked me to explain the pyramid shape of the Pascal triangle, and I'll initially do that triangle in the evening session first of all, and then it will be followed by pointers. It's a very important concept, pointers. Without pointers it will be very difficult for everybody to move to the next flow. So don't miss the next video. Just see it. I'll be explaining you about pointers very deeply. Okay, I'll be just explaining you about the pointers very deeply. Okay, so hope to see you in the evening session. Okay, thank you.